Hello everyone, this is Tutor Marife MCP. Welcome to my channel. In this video, I will teach you how to solve this word problem. This is an application problem in solving a quadratic equation. Specifically, it is a two-digit problem. Let's read it. A two-digit number is made of two consecutive numbers, such that the sum of their squares is 4 less than the number. Find the two-digit number. Okay, let's start. When solving a word problem, the first step is to represent the unknowns. What are the unknowns in this problem? We don't know what the units digit is. We also don't know what the tens digit is. So let's start from there. Represent the units digit as x. Represent the tens digit as x plus 1. Why x and why x plus 1? It's because of the given description that the two-digit number is made of two consecutive numbers. To represent two consecutive numbers algebraically, represent the first number as x, then the next number would be x plus 1. Okay, next, let's use the general form of a two-digit number, 10t plus u, where t is the tens digit, u is the units digit. Following this form, let's replace t with the representation of the tens digit. It's x plus 1, so we now have 10 times the quantity x plus 1. Then replace u with the representation of the units digit, so we have a plus x. Let's simplify this expression by clearing the parentheses. Use distributive property of multiplication. Distribute 10 into each of the term inside the parentheses. 10 times x is equal to 10x. 10 times 1 equals 10. Then copy plus x. Combining similar terms, 10x plus x is equal to 11x. Copy plus 10. This is the simplified form of our two-digit number. And this is what we are looking for. After representation, we will form our equation. And to form our equation, we're going to translate this sentence. The sum of their squares is 4 less than the number. In language of math, is equivalent to an equal sign. This phrase at the left of the word is will be the expression on our left side, and this phrase will be our expression on the right side. Okay, translating this phrase, our keyword is sum. Sum is equivalent to addition. So we have a plus sign here. Squares. This refers to the square of each digit. If the units digit is represented as x, the square of x is x squared. If the tens digit is represented as x plus 1, the square of x plus 1 is the quantity x plus 1 squared. The translation of the sum of their squares is x squared plus the quantity x plus 1 squared. Okay, next, let's translate this phrase. 4 less than the number. In language of math, less than is equivalent to subtraction. So we have a minus sign. And be careful when less than is involved in translation. From English expression, you have to translate backwards. That means if in English expression 4 comes first, in mathematical expression 4 comes last. The translation of 4 less than the number would be number minus 4. Remember that there is no commutative property of subtraction. So be careful with the order of the terms when doing translation involving less than. Okay, so following this pattern, the number is 11x plus 10. Then we have minus 4. Okay, So this is our equation in solving for x. Next step, let's clear the parentheses, expand the square of the binomial x squared plus, apply the perfect square formula, square the first term, it's equal to x squared, double the product of the terms, it's equal to 2x, square the last term, it's equal to 1. This is the expanded form of the square of the binomial. On the right side, let's combine the constant terms. 11x plus 10 minus 4 is equal to 6. On the left side, let's combine the squared terms. 2x squared. Copy 2x and 1. Then let's collect all the terms on the left side. Transpose 11x and 6 into the other side. When we transpose, change the sign of the terms. 11x becomes negative 11x on the left side. 6 becomes negative 6 on the left side. The right side becomes 0. Then simplify the left side by combining like terms. We now have 2x squared. 2x minus 11x is equal to negative 9x. 1 minus 6 is equal to negative 5. Equals 0. We now have a quadratic equation expressed in general form. And we can solve for x using factoring method, completing the square method, or quadratic formula method. Let's use the quadratic formula in solving for x. Let's define our a, b, and c. A is equal to the leading coefficient, it's 2. B is the numerical coefficient of x, it's negative 9. C is equal to the constant term and it's negative 5. The quadratic formula is x equals negative b plus or minus square root of b squared minus 4ac divided by 2a. Let's substitute our a, b, and c. X is equal to negative 9 plus or minus square root of negative 9 squared minus 4 times 2 times negative 5 divided by 2 times 2. And then let's solve. Negative times negative 9 is positive 9 plus or minus square root of negative 9 squared is equal to 81. Negative times negative is equal to positive. 4 times 2 is 8. 8 times 5 is equal to 40. Divided by 2 times 2 is equal to 4. 81 plus 40 is equal to 121. 121 is a perfect square. Square root of 121 is equal to 11. So we now have 9 plus minus 11 divided by 4. So our x is equal to 9 plus 11 divided by 4, or x equals 9 minus 11 divided by 4. Solving for the first root, 9 plus 11 equals 20 divided by 4 equals 5. The other root is x equals 9 minus 11, negative 2. Negative 2 divided by 4, reduce it to lowest term, it's equal to negative 1/2. But we are trying to solve for a digit of a number. A digit of a number cannot be a fraction, so let's discard x equals negative 1/2. Therefore, the acceptable answer is x equals 5. Going back to the representation of our two-digit number is 11 times 5 plus 10. And this is equal to 55 plus 10, or 65. 65 is the answer. We can validate our answer by going back to this statement. Let's see if this answer satisfies the given statement. The sum of their squares. So let's square 6 and square 5. Add them up. Is equal to 4 less than the number. Let's see if both sides become equal. 6 squared equals 36. 5 squared equals 25. 65 minus 4 is equal to 61. Add 36 and 25. This is equal to 61. Equal to 61. Therefore, we validated that 65 is a correct answer. There are two possible answers for this problem. The other answer can be solved by interchanging the representations. Instead of x equals the units digit, let x be the tens digit and x plus 1 be the units digit. And then solve for x. You will get another answer that will satisfy this statement. Okay? I'll leave that to you as your practice problem. This is all for this problem. If you have any questions or you want further clarification, feel free to use the comment section. Please don't forget to subscribe to my YouTube channel. Again, I am Tutor Marife MCP. Thank you for watching.